we're going to be going over a set of practice problems for stormwater runoff analysis. There's going to be problems where I give you the location and I give you a screenshot of the rainfall data table from NOAA's website. The only thing you'll need in addition to this is obviously a calculator, but also the civil engineering formula sheets so you can get the runoff coefficient and the adjustment factor. All right, so if we look at our first problem here, it's in Nashville, Tennessee, and the idea is that you have a 3-acre farm. So it's 3 acres, that's the size, and then it's farmland. For proposed development, you have a 30,000 square foot asphalt parking lot. And then the design storm is 25-year, 1 hour rainfall. All right, so going to the formula sheets for 25-year, the adjustment factor is 1.1. All right, so it's 1.1. C. Pre-development is always average. So for farmland, you can see it's between 0.05 and 0.3. So you take the average of 0.05 and 0.3. So 0.05 plus 0.3 divided by 2, and you get 0.175. The rainfall intensity for 25-year, let's see, 25-year, 1 hour, and you see that the rainfall value is 2.54 inches. Per hour. And then the total land is 3 acres. That was given in the problem. So Q pre is equal to CF, which is 1.1, times C, which is 0.175, times I, which is 2.54, times A, which is 3. And when you do that, you get 1.47 cubic feet per second. All right, so that's the pre-development runoff. All right, post-development runoff. So you must identify a new runoff based on the development, and it must be a composite or weighted average. And I've kind of helped you here a little bit. All right, all the other numbers are still the same. So runoff coefficient is still 1.1, the adjustment factor. The sub area 1, so we're going to say that's the parking lot. We have A sub 1 is 30,000 square feet, but we have to divide that by 43,560 to convert it to acres. And you get approximately 0.69 acres. All right. And then the remaining land, and let's just double check. Are they doing any kind of planting or developing? Nope, it's just saying they're really just turning the parking lot into something. So 3 acres minus 0.69 acres. There is a remaining land of 2.31 acres. And we're going to see here for C sub 2 is, so that's A sub 2, sorry, is still 0.175. Here, we need to know that, oops, don't need to go up, but the asphalt parking lot, if you go here, asphalt, its worst case scenario for post-development is 0.95, 0.95. All right, we don't have a third area, so you can just ignore that. So the weighted average, remember, it's the C sub 1, so 0.95 times A sub 1, 0.69, plus A sub 2, which is 2.31, times 0.175. All that divided by the total area, which is still 3. You type that all into your calculator. Be careful. You're going to put in parentheses 0.95 times 0.69 plus 0.231 times 0.175, close parentheses, divided by 3, and you should get approximately 0.35. All right, so that's the composite runoff that we're going to be using. I is still 2.54 inches per hour, The total area of the land is still 3 acres. So QPost is still 1.1 times the new C, which is 0.35, times I, which is 2.54, times A, which is 3, and you get approximately 2.93 inches per hour. Oops, wrote that wrong. Not 29 point. Let's try that again. 2.93 inches. Sorry, not inches per hour. Cubic feet per second. All right. So what is the difference between pre and post? So delta Q is equal to Q post minus Q pre. And so it is, if we look back up here, 1.47. So 2.93 cubic feet per second. I keep on doing that. 2.93 minus 1.47 cubic feet per second. And it's an increase of about 1.46. So you've almost doubled it. Cubic feet per second. This means it has increased. Right? The post-development minus the pre-development is a positive number, therefore it has increased. If there is additional runoff, what volume of additional runoff will there be in cubic feet per second after 24 hours? All right. So what you need to do is it's 1.46 cubic feet, so feet cubed for every 1 second. All right, so we need to kind of convert this to 24 hours, 1 day. So we multiply this by 60 seconds in every 1 minute. There are 60 minutes in every 1 hour, and we're doing this for a total of 24 hours. And if you want to, just as a placeholder, put it over 1. Seconds divide out, minutes divide out, hours divide out. So you're only left with cubic feet. And then you could figure out the volume of your detention basin if you needed to. You multiply this all out. So 1.46 times 60 times 60 times 24. And you get approximately 126,144 cubic feet of water that you would need to store temporarily on site before letting it drain out somewhere. All right. So we're going to keep on going over problems similar to this. The only thing is I'm going to kind of take away some of the supports, where I did the composite runoff, give you a little bit of support here on number 2, but on number 3, totally take that away, and it's up to you to figure it all out. All right. So make sure you review this, and then we will go over the next problems in the next video.